gaffing for you is Doug Taylor. My name is David Spurgeon. I'll be helping him out with the next set of hands. So that is a gather of glass. That is clear glass kept at over 2,000 degrees to keep it in a softened state. Also makes it glow orange. That is not orange glass. That is a clear base that we will be adding a coloring component, and that's going to be glass as well. But it's had different metals added to it, different oxides, different forms of copper, cobalt, silver, gold, nickel, tin, all sorts of different metals. Give you all sorts of colors depending on what else you add with it. Purities. Right now what he's doing is he's taking that gather and he's marbling it, which is shaping on top of the marble table, getting it stained from the material it used to be made of, marble. These days we all use steel. It's not going to crack and chip like marble can, and it's considerably less expensive. And you can use stainless steel, which has the added benefit of not rusting, but not quite as cost effective. And now that that's cooled enough, and he's popped a little bubble into it, he knows that there isn't glass that's been pushed up into the opening of that pipe, which would cool and then act as a plug if he wouldn't be able to blow air into it. Just having the bubble pushed off the tip of the pipe a little bit lets him know that that's unobstructed. Now there's only so much you can pull up on that small diameter pipe, and each time you increase the surface area, you can pull out a lot more glass. And by touching it down inside that scoop, those little pieces of colored glass will immediately heat up and stick. Hey girls, come on in. We have Doug Taylor blowing glass. There's no real break in the action. So far he's just pulled a little glass out of the furnace, and now he's adding color to it. And inside those scoops he has a canary yellow and is that a violet or something? A translucent purple. Now canary is an opaque color, very brilliant in color, but light does not pass through this readily. And that crushed up version of the color is called frit, F-R-I-T. Now we also have these bars of color, densely colored glass, and stretched into these uniform bars that we could knock off the chunk, heat up to about 1,000 degrees, and then stick on the end of the pipe, trail it on the opening, trail it around the bubble, all sorts of different techniques, different powders. Right now he's getting the glass hot enough that it's soft enough that he can put a pattern into the color. And the way he tells the temperature of the glass is how it moves on the end of the pipe, not so much the glow. By inverting it into one of these cast aluminum molds called optic molds, it'll put an impression in the glass. Sometimes we use that to put an actual shape on the bubble. If you blew that out into a bubble right now, you'd end up with a ball with kind of ridges on the outside. In this particular case, he's using that mold as a way to influence the color pattern. So now that that bubble has ridges all over the outside, as he grabs it with that pair of shears that has a triangle cut out of each blade, making a diamond in the middle, we call these diamond shears. It'll crimp down all those lines to a central point right at the tip. Now these little buttons you see up at the front desk in a bowl, what he does is grinds off that first layer that has the color on it, and then he has multiple different pads he has to use, almost like different grades of sandpaper, all the way down to a cerium oxide pad, which will cause it to look polished and nice and clear. Also twists that design up, and as those high and low points get compressed together, it's going to condense the color down along the low points. So eventually that's going to be smooth again, and in the place of the three-dimensional pattern will be the color pattern. As you can tell, that doesn't look like canary yellow. The purple's pretty dark. But once that cools down, the colors will pop back out. But while we work with them, they always look pretty dark. So got to go through the long, uniform cool down cycle called the annealing process, in which the glass will evenly cool, get rid of any stress in it, and it'll also make those colors pop back out as they cool. Now the reheater it is using is about 2,500 degrees, so that's going to get the glass up to the 2,000 degree softening. It's kind of softening point that we need. If we actually got the glass all the way up to 2,500 degrees, it would be very loose or very thin. It would be kind of watery. We wouldn't want to kind of hold ourselves together on the end of the pipe. That's more for pouring into molds. We need more of a consistency of kind of like honey. And this 2,500 degree heater gets us up to that temperature quickly. So by rolling it back and forth across the table, he's going to put a chill or a little bit of a skin on the outside of the glass. And that slightly cooled texture on the outside will give just a little bit of an even kind of resistance as he blows it out. Now, not the type of resistance that a balloon gives, where it's at one size and you're stretching it and it's trying to shrink back to that original size, but just that slightly cooled exterior gives it an even resistance as it blows out, so it blows out evenly. And each time he blows the bubble out a bit, he's rolling it back down. What that's doing is it's letting the bubble blow out and then it's compressing it back down. It's also cooling the sides, so that bubble is kind of pushing down through the center, and he's going to have more of an elongated bubble than a spherical bubble with a long, solid mass at the tip. If that were the case, the side walls would heat up very quickly, as they would be much thinner than the tip, and it would cause the bubble to kind of collapse on the bubble side. So if he goes back to get more material while the bubble is still hot, putting it in that 2,200 degree material would cause it to soften very quickly, possibly causing the bubble to collapse down, or even strip off the end of the pipe once it's softened or loosened up enough. But by cooling it down to close to 1,000 degrees, which obviously sounds ridiculously hot, but for glass blowing is extremely cold. It becomes solid at 950 where it can start to crack, so we have to keep it above 1,000 all the time. With that temperature range, if it gets too cold, putting it in there just causes it to shatter. But by cooling it, it is going to hold its shape a little longer, allowing him to get over to the pipe cooler. And that just shoots room temperature water onto the pipe, quenching it, allowing us to get our hands closer down toward the weight. And these pipes are aircraft grade stainless steel, so once the heat's pulled out of it, the hot glass on the end of the pipe is not going to gradually heat the whole pipe back up toward the mouthpiece and burn us. So keep it down the first foot or so of the pipe. Roll that back down. And before we start expanding a piece, you really want to make sure that the material is evenly distributed, that the heat is even across the bubble. Otherwise, as you blow into it, it just goes to the softest spot. That's the hottest area, which is going to be that part that's rolling right now. That's the area that sits furthest in the heating unit, sits right in front of the burner. And it kind of shields the back with its mass. So as that heat's hitting the front, it's not hitting the back as much. So it takes longer for the back to heat up. If you go in and just soften the front before the back part connected to the pipe softens and you blow into it, it doesn't expand by the pipe, it just pushes down toward that soft tip. So you either have to accumulate the material in such a way that there's more of it at the bottom, or you have to really watch the heat cooling it where it needs. Now the tool he's about to use are called scissor jacks, and this is used to make the compression mark which will dictate where he pops it off the pipe once it's done. Once he breaks that bubble off the pipe, there'll be an opening left from disconnecting it from the pipe, and that becomes the opening of our base or bowl. And as he squeezes this jack line down, preventing it from getting any bigger, He's also blowing air into that hose, which is connected to the end of his blow pipe. That's going to expand out the bubble. I'm just upping the difficulty by blocking his view. We have to use these to shield each other's hands. Our hands are right next to that bubble. I feel the heat all the way back here. So if you didn't have this shield, it gets pretty uncomfortable pretty fast. It's also the reason we wear those Kevlar sleeves. We usually double them up. The arm is right next to a bubble, and as it expands, and it's anywhere from 1,500 to 2,000 degrees, it starts to roast your arm. Even the pads don't really block out all the heat, but everything helps. You just have to be efficient with your movements. Have your arm in the correct place. Now he's got the bubble started. Anytime you see him swinging the pipe or holding it down, he's using gravity. That pendulum action using that to kind of elongate the bubble without touching it with a tool. Anytime you touch it with a tool, you kind of cool it down quickly, and you can leave tool marks. He's got those boards put in a V that'll adjust to different size bubbles. And then having the wet newspaper in there allows you to shake it. And because the newspaper is wet, the hot glass is causing the water in the paper to be emitted from the pad as pressurized steam. And that prevents the two materials from touching the sticker. We're just blowing that out, watching the thickness at the bottom. Doesn't want that to get too thin. And once he has the bubble blown out evenly, we can return to the heat. Okay. Yeah, that. Alright, so I'm going to get some material and into this rod. Just a little bit at first. I'll wait for this to cool just a second, and I'll go back and get another gather. Light the hand torch. Once I get the next gather, I'm going to drop it into the mold. Get a little impression on it, probably just hold it. We'll use that torch to keep the back end hot. Typically, I'm not going to stop the rotation like that, but it'll show you the rate at which the glass is falling. So I'm going to go ahead and give another gather. This will give me enough material. I'll go ahead and drop it into this mold. Top it. Attach it, give it a turn, which will make those optical impressions twist on each other. Press that off. Now he has a transition from the bubble into the base. Okay. He's going to do some shaping. I'm going to get another gather, allow that to cool slightly, and then we're going to use this as a base, dropping it on the steel top table and touching it down to the tip of that bubble. Just got to cool a little bit more. The rate at which it's falling is going to depend on how much glass is on the end of the pipe. It takes longer for a longer amount to cool. If it cools too much, it's not going to heat back up enough to zip off the end of the pipe. If it's not cold enough, it won't pull up enough material. Go ahead and drop this on the table. Down, down, down. Yep. So once that's attached, right back into the heat. Does lose a little bit of its temperature sitting on top of that steel table. So just by heating up that bottom, it'll have a little bit more of a consistent heat. You don't want a slightly cooled bottom and then very hot top. You go to shape it, that bottom's going to cool a lot more quickly. You really want it to kind of flow into place. Sorry if I get in your way, you might have to keep around me. I have to give them a flat board to work against. Lightly pushing whenever I see them turn the pipe. Releasing the pressure if it's not. He's angling out the jacks. All that shouldering. Now we're getting a nice even taper to the shape and thickness. Once he's happy with that, we actually make what's called a hunty. And this will be just a little bit of glass wrapped around the end of this rod. A little bit of glass, the only thing that's going to hold it on, and it's much too soft right now, so I have to make sure it's going to support the weight of that base, so I have to cool it, and it has to be evenly shaped. So just time the shaping process so that the steel pulls enough heat out of the glass that it's at the right temperature. So I'll go ahead and shape it so there's a little bit hanging off the end, even out the sides. Cool it just a little more, and refine the shape. Leaving a slightly stiffened cylinder clear. Kind of like the consistency of tapping. And that'll allow it to stick and hold until the end of the process. Once it's attached, to line up the pipes using the diamond shears. And once those are lined up, you can disconnect the bubble from the pipe using a quick cool down at the jack line. Now that causes a lot of stress, causes little microfractures all around the circumference of the jack line. And that cold spot in between the two hot spots of the glass wrapped around the tip of the pipe called the Morean and the bubble itself causes the stress area to crack free. Get it in for a couple quick flashes, make sure that the glass is hot enough that it's not going to crack, and then concentrate the heat where he wants to do the shaping the most, which is going to be, depending on what shape he wants to finish up with, anywhere from the whole thing to just the top half. Gotta be real careful not to hit the edges. Hot glass sticks over hot surfaces, and that whole thing is glowing, so that's definitely hot enough to stick. Jacks. Start to open that up. Then you can use a tool called a steam stick. And this is another one of our saturated wooden tools. It's got a sharp cone that goes to a wider back end, and that adjusts to different size openings. Now the wood is so saturated in water that when he makes a seal, that steam shoots into the bubble and expands it from the other side. And that's used for shaping as well as thinning out the glass and making it a lot more even. Now he's going to do a controlled heating in the top half. So what's it cool is that orange will be a bright yellow. There's some violet. Maybe it's purple. Type it comes. Under the other right there.